Welcome to OSDU Data Platform Application Developer Training. In this presentation, I'll talk about the search service, which represents a pattern for delivery. I will explain how to create data and provide some examples. The search service allows to do performance queries on data based on text search, field ranges, field match, sort, aggregation, filters, geospatial coordinates, limits, and pagination. For this, it provides an API to do queries, queries with cursor, and cross-cluster queries. In order to use the search service, the minimum required permission is a service search user group, and you should also belong to the search records ACLs as viewers. Now, I would like to say a few words about what is under the hood. After a record is uploaded, the indexer service reads the record data and its schema to properly index into Elasticsearch. So every record in the system has an associated document in Elasticsearch index. Queries are performed against the Elasticsearch index. To issue a query, we use a JSON-style consistent domain-specific language, and I will give you examples of query syntax. This example is the anatomy of a query. It shows all possible fields of a query. I will explain in detail each of those fields. Kind is the only required field and represents the kind of records to search for. Query is a query string based on Lucene query syntax. Offset, a number, the starting offset from which the return results. The default equals 0. Limit is the maximum number of results returned in request, defaults to 10, and has an upper bound of 1000. Sort allows sorting on specific fields in ascending or descending order. Query as owner is the boolean to fetch only owned resources, defaults to false. Spatial filter is an object to perform geospatial queries, dependent on the mode. It has different properties. Track total count is a boolean to track accurate record count. Return field is a listed field on which to project the results. Aggregate by is the name of the field to aggregate by. Let's start with doing the simplest queries, the one that only has the mandatory field. Please note that is case sensitive. You may optionally use wildcards on any of the sections of the kind. If we put in the last section, we will get records of any version. If there is a wildcard in the third section, we will get records of any type, wells, wellbores, trajectories, and so on. Here, the query property is used to create queries complying with Apache Lucene syntax. In the first example, the search is for all wells that contain the BIR in any field. Next, search for all wellbores where the well ID field contains both well and 100 plus something else. In the last example, we search for all wellbores whose ID match the text, and it will return only one result. The search allows multiple level sorting on a list of fields. It does not validate if the field exists or has a comparable or supported types. Most of the fields can be used for sorting. You just need to be careful to validate that fields are comparable and supported for sorting. In this query, we search for 10 deepest well logs and rate them according to the bottom measured depth. Aggregation by any field yields a count of all distinct values for that field. So, you can get the number of records with each value of the field. In this example, we count how many records are for each kind. You can search for fields values within a range, and you may specify a range for date, numeric, or string data types. Use a square bracket for an included boundary and curly bracket for an excluded one. In the first example, we search for well logs between 2,000 and 3,000 meter deep. And the next query will return entities spawned in the 20th century. The search service supports geospatial queries. Since an entity may have a latitude and longitude properties, you can find them in the search service. For this purpose, use spatial filter in queries. There are three modes of geospatial search: by distance, within a specified distance from a point; by bounding box, within a specified square; by geopolygon, within an arbitrary polygon. And here is an example of a query for wells within 10 km distance from the point. Arrays of objects can be indexed in one of two Elasticsearch types, as a flattened object or as nested object. In the case of nested objects, you must use the nested query function. First, you specify the array name and then the fields and their values. So, this example queries the copper shell layer deeper than a kilometer. If your query returns big number of results, you may want to paginate them. And you can achieve it in either way. First, you can use the query with cursor endpoint to retrieve large numbers of results from a single search request. Or you can specify the offset and limit attributes in the request body. Here is a collection containing many requests grouped by type. The first request looks for all entity types of any version in the OpenDES partition. These are the first records, and the total count is 10,000. Let's try a text query. This one searches for any field containing the string BIR. Now, if we look at the results, we can see that the search fetches record with BIR in any text field. We can also sort the results. Here, we sort well logs by the bottom measure depth in descending order. So the first result is the deepest across the well logs uploaded to the system. Let's try range queries. We're going to find the well logs with the bottom measure depth between 2000 and 300. So in the results, we can see that all the values fall in the specified range. Now I'm going to show a nested object query. Here is a special function to search nested objects. The array named data markers as the first argument and the second arguments are the nested field and their values. The kind is wellbore marker set. I have got results with a copper shell layer deeper than 1,000. Geospatial queries are another more interesting. This request searches for well logs and the field to be processed in spatial location. WGS 84 coordinates. The mode of geospatial query is by distance. That means entities will be searched within a circle. So by distance object requires two fields, the center point coordinate and the distance, the radius of the circle. In the results, I get wells located in the circle, in this case, only one. And finally, pagination. I will show pagination with cursor. The URL is slightly different, yet the syntax is the same. I'm covering all wellbores. The system returns the cursor to fetch subsequent resources. The cursor key has been saved to variables. So I'm sending the request to get the next one resources.